Okay, so welcome back, and in this example I'm going to show you two more examples. This one I'm going to solve one way, but this one I'm going to show you two different ways to solve this. You get the same answer, and the reason why I'm going to do that is show you that there's lots of different ways you can come up with the same answer, okay? As long as you isolate the variable on one side and you get everything else on the other side and you simplify everything, you're going to get the correct answer as long as you do all the operations correctly and don't make any mistakes with signs and things like that, okay? So in the first one, let's see what happens with this equation here. So again, we want to combine like terms on both sides, and then we want to move any term with x on one side and any constants to the opposite side, okay? So let's do this first. So let's combine these, and so we get 3x minus 7 equals 3x minus 11. Okay, now what I'm going to do is I'm going to move the 3 over to one side. I got to move the x's to one side. So I'm going to subtract 3x from both sides. And as you probably already noticed, what's going to happen? Well, 3x minus 3x is 0. 3x minus 3x is 0, and what do you get? You get negative 7 equals negative 11, which is a false statement. Okay? It's never true, right? It's a false statement. So what does this mean? One, x dropped out. X is gone, and all you're left with is a false statement. This means, very similar to an identity, it means it doesn't matter what x is. Okay? What this means is that there's no value of x that will ever make this true. Okay? So that means there is no solution to this equation, because all you end up with is a contradiction. Okay? So if you end up with a contradiction, a false statement, where again you have no x and you just end up with some false statement that's never true, that means there's no solutions to this, and we call these types of equations contradictions. Okay, so now there's that equation. So there's that type of equation. Okay, so these are contradictions. The other one, if it's you get a true statement, is called an identity. Remember that. This is called a contradiction. Okay. Now, what about this one? So let's do this one, and I'm gonna solve it two different ways. So first, let's move all the x's to the left. Okay? Because again, we've got to bring all the variable terms to one side, all the constant terms to the other side. Okay, so let's do that. So let's subtract 6x from both sides. Okay, now, if I'm moving all the x variables this side, then I got to move all the other constants to this side. So let's subtract 2 from both sides. Okay, there's nothing wrong with doing it in one step. If you want to do it in separate steps, by all means, if that helps you and this gets confusing, just do it in 2 steps. Okay? So I'm subtracting 6x from both sides, and I'm subtracting 2 from both sides. Why? Because I'm going to move the x's to the left, I'm moving the constants to the right. And so now 6x minus 6x gives me 0. 2 minus 2 gives me 0. Now then here I get 9x minus 6x, which gives me 3x equals, and then I get negative 10 or minus 10 and a minus 2, which gives me a negative 12. And so now I get 3x equals a negative 12, and then I just divide both sides by 3, right? 3 divided by 3 is 1, so I get x equals negative 4, right? And I'm done. Now let's do it another way. So let's say I have the same equation. So 9x plus 2 equals 6x minus 10. So now let's do this. Let's move everything to the left. Let's move the x variables to the left, let's move the x variables to the right and move the constant terms to the left. So now what I'm going to do is I'm going to subtract 9 from both sides, right? Because I want to move the 9x over here. So I'm going to subtract 9x from both sides. And now I'm going to move the constant terms to the left, so I'm going to add 10 to both sides. And so again, what happens? This is going to go to 0. This is going to go to 0. And so I end up with what? 2 plus 10, which is 12, equals 6 minus 9x, right? Which gives me a negative 3x. Okay? Now what I'm going to do is I'm going to divide both sides by negative 3. Or if you want to multiply both sides by negative 1/3, that's fine too. Okay, so negative 3 divided by negative 3 is 1. And so what do I get? I get, and then 12 divided by negative 3 is negative 4 equals x. So notice I get the same answer. I get x equals negative 4 or negative 4 equals x, same thing. Okay, so there's, again, as long as you use the properties correctly and you combine like terms correctly and you use the axioms correctly, you'll get the same answer. It might be switched, but that's okay. Have a great day.